Once again, good morning to everyone. I would invite Deepashri ma'am to start the session.
Okay, good morning. So let's start with today's session. My screen is visible, right? Okay. So, so yesterday we were learning about the different types, the process of the thermodynamics, and we have started with the reversible and the irreversible process. Okay, so today we will be doing the work calculation. Okay, so today we will be doing the or starting the work calculation. So first understand the setup and accordingly we will solve. Okay, so suppose this is a container which is filled with the ideal gas. Okay, so just like yesterday, this is a container which is filled with ideal gas, and the initial level of the ideal gas was this. Okay, this is the initial level of the ideal gas, and I have considered the initial volume to be V2 here. Okay, now this is the piston. Now you have pushed the piston, you have applied a pressure on this piston, and thus this piston has gone down up to this level, and thus the ideal gas got compressed here. Okay, so this is the external pressure which you have applied against this piston, for which this gas got compressed, and this is our new volume. This is V1 is the new volume, and the change, initially it was here, then it was here after applying pressure. So the change in the displacement is this. Okay, so from here to here, so how much it changed? It was this up to x, but the area of the cross section, the area of the container remains same like before. Okay, so this is the entire setup. So this setup is clear to everyone? Yes or no? This setup is clear or not?
Yes, ma'am.
Okay. So what is work? In your physics, you know that work is force into displacement. Right? Okay. So again, what is force? Force is equal to pressure into area. Pressure into area. Okay. And the displacement remains as displacement. Okay. So what is pressure? So if I just substitute by this, pressure is P, area is this A, and what is the displacement? Displacement is this X. Okay. Now, if I just keep this pressure outside and A and X together. We can write like this. See, area and displacement. This area and displacement. Okay, area into displacement is what? Volume, right or not? So pressure into volume. Okay, so pressure into volume, but we write it as change in volume. So pressure into change in volume. So what is the definition for work? Work is equal to P del V. Is this derivation clear? See, there are different types of the work done. But in thermodynamics, we consider only the PV work. What is this? This is the PV work. We don't consider any other work. We consider this PV work only. Is this part clear?
Yes,
Yes or
ma'am.
no? Good. So this is the standard definition for PV work. Now, so this is some of the important, this is the formula you need to remember. Work is equal, W is equals to PV work. Now, work. This work can be of two types, okay, which is work done on system. Work done on system means negative, right? Sorry, work done on the system means positive, right? Yesterday I told you. And one other thing is work done by system. Okay, it is negative. So if someone says work is done on the system means it is compression work. Okay. Now, if someone says work is done by the system, it means expansion work. What is compression work? Compression work means this, you are applying the pressure and the gas here is being compressed. What is expansion work? There is the external pressure is less than this internal pressure. So this gas exerts an outward pressure like this. Okay, so the gas is expansive. Expansion of the gas occurs. So expansion work is negative. Compression work is positive. Compression work is work done on the system. Expansion work is work done by the system. Is this part clear up to this convention? Remember, if in your question the anything is not mentioned, work done is on the system or work done is by the system, then always consider by the system. If not mentioned in question, then work done by the system. You have to consider. So up to this part is clear to everyone?
Yes,
Okay,
ma'am.
good. So now let's just start. Okay. Now what are the units? Units. What is Q? Q is heat, right? Q is the heat. And W is the work done. We have learned about this yesterday also. 1 calorie is equal to 4.18 joule. For your calculation, you will consider it to be 4.2 joule. Okay, for your calculation. In your boards, you will do with 4.18. In your NEET exam or JEE exam, consider 4.2 joules. Okay? Okay. 1 liter atom is equal to 101.3 joules is equal to 24.2 calories is equal to 101.3 into 10 to the power 7 R. Okay, this is the main calculation. But What I told, this is something for your boards you will do, but for your NEET, you will write it as 100 joules, 24 calories, and 10 to the power 9 erg. Is this unit part clear to everyone? Where to consider what? Yes or no? Now let's just solve a question. When 1 mole do it. It's an easy sum, very easy sum. So what it is said that 1 mole of a gas expands. This is your keyword. Okay, this expand is your keyword. I told you expand means what? The work that you will be getting, that will come in negative value. So expands from 1 liter to 5 liter against constant atmospheric pressure. Find the work done. Okay. So P external is given as constant atmospheric pressure. Atmospheric pressure is 1 atm. Okay, remember this. It is 1 atm. Delta V. Delta V means V2 minus V1. It is 5 liter minus 1 liter is equals to 4 liter. So what is the work done? P delta V. So what is P? 1 atm into 4 liters is equals to 4 liter atom. In my last page, what I told, to convert liter atom into joules, you have to multiply it with 100. So, this much joules. So, answer will be 400 joules. Is this sum clear to everyone? Is this sum clear to everyone?
1 second, can you explain?
Okay, see, if read the question very well. Okay, first, when you are reading the question, see, it is said that the gas is expanding. Okay, I told you if expansion occurs, what happens? I just told you here that if the expansion occurs,
Negative.
see, you will get the final answer in negative. Okay, if the expansion occurs, first hint. Now, what happens against what is our external pressure? Constant atmospheric pressure. Okay, atmospheric pressure is considered to be 1. So P external is 1 atmospheric pressure. Now delta V is V2 minus V1. Okay, so what is our formula? Now, see, this is the formula. This is the formula we have derived just now. Okay, so what I've written, W is equals to P del V. P is 1 atom and delta V is V2 minus V1. 5 liter, 1 liter. Okay, this is our V2, this is our V1. Final volume, initial volume. It is final and here it is initial. So it is 4 liter. So W is equals to P del V. So 1 atom into 4 liters. So it is 4 liter atom. So 4 into 100 joules or 400 joules. How liter atom is, see, 1 liter atom means 100 joules. Okay, I just wrote it here for your calculation in your NEET, what you will do. So here 4 liter atom, so 400 joules. Is this part now clear? Is this sum clear?
Yes, ma'am. Yes, ma'am.
Good, good, good. Now we will be drawing certain conclusions from first law of the thermodynamics. Conclusions from first law of thermodynamics. Keep making your notes during the class. Okay, what was our first law of the thermodynamics? Delta U is equals to Q plus W. This was the first law of the thermodynamics, right? Oh, wait. Start with the isothermal process. Okay, what is isothermal process? Delta T is equal to 0. Yesterday I told you for isothermal process, delta T becomes 0. And if you have revised the last class, you will remember that for isothermal process, delta U is also equivalent to 0 because delta U depends on temperature. Temperature is 0, delta U is also 0. Right or wrong? Now, according to first law of the thermodynamics, Q delta U is equals to Q plus W. So 0 is equals to Q plus W. So Q is equal to minus of W. Right? So what does it mean? Heat absorbed by the system is equivalent to negative, heat absorbed by the system is equivalent to work done by the system. Q is positive. Q is positive means heat absorbed by the system. W is negative means work done by the system. Is this part clear to everyone? If you have revised, you can get this well. Is this part clear?
Yes, ma'am.
Okay. So this is something you have to remember for your isothermal process. Okay. For isothermal process. So that I will be making you do the sums tomorrow. But today, just revise whatever we have done. Yesterday's class, today's class. Then tomorrow we will be solving the sums. Okay. So next comes first isothermal, then isobaric process. What is isobaric? No one is revising. See, for isobaric process, you can't do any short tricks. Okay, so our isobaric process, delta U is equals to Q plus W. There is no special conditions for isobaric process. In your isobaric process, either Q, W, both the values you will be given. You have to find this delta U, or something among these two values will be given, okay, to you. And accordingly, you have to solve the question. So for isobaric process, there is no such thing. Next comes isoporic process. Okay, so isoporic process. So in isoporic process, what happens? Delta V is equivalent to 0. Okay, volume remains constant. So delta V remains 0. So what is the definition for work?
Ma'am,
Minus P delta V. Now, instead of writing minus P del V, I can write this as
ma'am,
minus P external delta V. Yes. Say, someone is saying ma'am.
from the isothermal equation Q equal to minus W, can't
Ah.
we write substitute W or Q value in the isobaric?
This is only for isothermal. Don't mix this with this. Wait, I'm writing. Never mix this with this. Okay.
Okay, ma'am.
This is isobaric process. This is something only for isothermal process. I will teach you how to do sums. I will teach you tomorrow. This, see, why Q is coming to be as minus W? Because these are the two conditions for isothermal process. In isobaric process, for delta U, Q, W, anything is not something equal to something. So you can't write that. Again, in isoporic process, delta V is equal to 0, right? Right or wrong? So that is the reason we can do this. Here delta T is equals to 0. This is only for isothermal process. This is only for isobaric process. This is only for isochoric process. Okay. Yes or no?
Yes, ma'am.
Good. Now see, delta V is equals to 0, and this is the normal definition for what? So I can write it like minus P external, delta V is 0. Okay. So work done is 0. So for isobaric process, remember, for isobaric process, the work done is always 0. Sorry, isochoric process, the work done is always 0. Okay, remember this. Or isochoric process, the work done will always be 0. Now, can I do? Now, this is something you got. What is the first law of the thermodynamics? Delta U is equals to Q plus W, right? This is our first law. Q plus 0, that is Q. So, delta U is equivalent to Q. Now, this part is clear though. This part. Yes or no? Everyone. From first law of the thermodynamics, I have written this. Delta U is equals to Q plus W. Now, W is 0. From here, I have written that. So, delta U is equivalent to Q here. Is this part clear up to
Yes,
this?
ma'am.
Good.
Yes, ma'am.
Now, instead of you have got this. Now I am writing a small v here. Okay. Why I have written small v? QV means heat absorbed at constant volume. Okay. Now what we are seeing, that if the volume is constant, then delta U becomes equivalent to QV. Is this correct or not? Whatever the statement I made, that at a constant volume or for an isochoric process, delta U is equivalent to QV, right? Now, we know that delta U is a state function. Yesterday's class, I told you the list. Delta U is a state function and Q is a path function. But QV, this QV is a state function. Always remember this. This is very, very important. This comes in your exam. Okay, so from this, I have made this conclusion that delta U is equivalent to QV. Delta U is a state function. Okay, from yesterday's class. Q is a path function. But when delta U becomes equivalent to Q at a constant volume, okay, this is the constant volume I have written, then it becomes a state function, just like delta U. Is this part clear? Have I made myself clear to each and everyone? Yes or no?
Yes, ma'am.
Yes, ma'am. Try replying fast, then I will be solving a lot of questions with you. Then for cyclic process, what happens for cyclic process? Cyclic process, in yesterday's class, I told you that for a cyclic process, all the state functions are 0. Since all state functions are 0, today I will not be starting with the numericals because no one is replying to me. I think you have not revised, but today you have to revise everything and come in tomorrow's class. Tomorrow you will be just doing the numericals. Okay. Now, cyclic process means all the state functions are 0. So, delta U is equal to 0. According to first law of the thermodynamics, delta U is equals to Q plus W. So it's 0 Q plus W. So it is Q again equal to minus W. So it is just similar to isothermal process. Okay. Here it was delta U 0 for different see here delta T was 0, for which delta U becomes 0 because delta U becomes equivalent to delta T. But here, since in a cyclic process all state functions are 0, hence delta U is 0. Is this part clear? Here delta T is not 0. Okay. But ultimately, after calculation, we see that for a cyclic process, Q is equivalent to minus W, which is very much similar to our isothermal process. Okay. Now, there is one more system, which is the adiabatic. Remember, adiabatic system is a kind of isolated system. Okay, adiabatic is a kind of isolated system. Now, for what happens for this? In isolated system, here Q is equivalent to 0. There is no heat transfer. Q is equivalent to 0. So, okay, according to first law of the thermodynamics, delta U is equal to Q plus W. So, delta U is equals to 0 plus W. So, W. So, delta U is equivalent to W. Now, again, delta U is a state function. Right or no? Delta U is a state function. Only W is a path function from yesterday's class. Now, delta U is equivalent to W at what condition? When there is no heat transfer, and when there is no heat transfer, we called it as adiabatic process. So delta U is W. Here we can write it as adiabatic. Okay, like this. So for adiabatic process, delta U is equivalent to W adiabatic. Okay. So delta U is a state function which we know from yesterday's class. Only W is a path function which we know from yesterday's class, and W adiabatic. Okay. So this W adiabatic, this becomes equivalent to delta U, and delta U is a state function. So W adiabatic becomes a state function also. Again, this is very, very important. This question has already come in your exam. So up to this, is this part clear?
Yes, ma'am.
Whole, whatever conclusions we have made from first law of the thermodynamics, remember, if it is isothermal, use this. Isobaric, use this. Isochoric, use this. Cyclic, this. Adiabatic, this. Don't mix one form to another form. Okay, the boy who asked me, is this part clear?
Yes, ma'am.
Okay, so now these are the conclusions. Now we will be starting with work calculations. Work calculations. Again, let's start with isothermal process. Okay. Before writing this, what is our general formula for work done? W is equals to minus P external delta V. Okay. So this is from this. We have started here. This is our conclusion. This is the basic definition for work done. Okay. From here, I can write what is the work done? Work done is minus P external delta V. This is the general formula for work done in chemistry. But if the system changes, this formula will change accordingly. Okay. Now, how? Let's start with isothermal process. Okay, what is an isothermal process? Isothermal process means delta T is equal to 0 and delta U depends on delta T. So delta U will be also be 0. This is our isothermal process. Now for the isothermal process, there are two cases. Case 1, irreversible isothermal process. Okay, irreversible isothermal process. Now remember last class, yesterday's class, I concluded with reversible and irreversible. What was irreversible thing? This. So what happens in an irreversible thing? This is our whole system. We placed a brick and immediately the piston went down. From here it went to this level, right? So from here it went to here. Okay, so the level was not the same. So initially the level was like this and now the level is here. Okay, so this is our irreversible process. Now, in this irreversible process, what happens? A brick is placed and immediately the piston goes down. So it is a fast process. This reaction happens immediately. Okay. So there is immediate reaction. This is our irreversible process. Remember the irreversible case. Now, how we will solve the question? I told you the definition for work done. Basic definition is minus P external delta V. Okay, so minus P external delta V means what? V2 minus V1, right? And I told you that in this system there is an ideal gas. Okay, now we will be replacing V2 with NRT form. Why? Because for an ideal gas, we can write like PV is equals to nRT. So what is the value of V? nRT by P. Okay, can we write like this? Why can we write like this? Because it is an ideal gas and we already know this. So V1 will be nRT by P1 and V2 will be nRT by P2. Okay. So substituting this value, what can I write? nRT by P2 minus nRT by P1. If I take nRT common into nRT, 1 by P2 minus 1 by P1. So, in your question, if they ask you irreversible isothermal process, okay, this is the formula you are going to use for work done. This is the formula you are going to use for work done. Is this part clear? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Good. Now, this type of question can come in two formats. In your book, in your NCERT, in your Neet, in your JEE, in your advance also. If P external is given, then you can just put the values and get the answer. Okay, it is easy. But suppose in your question, we will practice also, P external is not given. Different pressures are given, 2-3 pressures are given. Okay, then in your question, if there is something written as P external, then consider it to be your, sorry, if anything is written as P2 or the final pressure, then consider it to be as the P external. Okay, if it is given, no problem. But in your question, 2-3 pressures are given. And in your question, it is mentioned this is the final pressure. Consider that final pressure to be P external. Okay? Clear? This part? Yes or no? Just
Yes,
reply.
ma'am.
Good. Now, what are the units you will be considering? Some people are always confused what to consider as unit. Whatever I am telling the units to consider, you will consider that only in your boards, in your NEET, in your whatever. Okay. So R, C, P external. This P you will be getting in atom. Something atom will be given to you, this P external. Then what comes? N. N will be given in moles. Okay. R. R you will write it as 1/12 liter atom per mole Kelvin. This is the value for R you will get. Okay. nRT. T you will be writing it as Kelvin, not in Celsius. Not in Celsius. nRT, then other P, this P you will also be getting in atoms. Okay, so any kind of pressure you will be writing it as atom. And if volume is given, sometimes volume will be given also. So volume will be given in as liter. So if you use these units, you will be getting the work done in liter atom. Okay, and I have already taught you to convert liter atom to joules. You just need to multiply it with 100. See, to convert liter atom to joules, you just need to multiply liter atom with 100. So you are getting your, if you use this unit, if you are using these units, you will be getting the work done in liter atom. So whatever you are getting, multiply it with 100, you will be getting your answer in joule. Okay? Divide this answer by 1000, you will be getting the answer in kilojoule. Is this part clear? What units you will be considering? Yes or no?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Enthusiastic, yes, or you are just till now shy to say me, ma'am, I don't understand.
Excuse me, ma'am.
Yes, ma'am.
What is the value of R, ma'am?
1/12 liter atom per mole Kelvin.
Is it 8.314?
Yeah. You will be writing it as 1/12 because if you write 1/12, you will be solving the questions easily. Tomorrow's class, I will show you. Okay.
Okay.
That 0 point thing, I wrote it as 1/12 so that it becomes easy for you to calculate. Now, case 2. Did you remember the case, what we were doing? Case 1 was irreversible isothermal process. Now, case 2 is reversible isothermal process. Reversible isothermal process. Okay. What is reversible? Reversible is that thing that you remember that we were putting sand on top of it and the pressure was not decreasing immediately and it was taking some time. Here we were putting grains of sand and the piston was slowly going down. And here also the ideal gas was exerting some kind of pressure on it. Right or wrong? So here multiple small steps were occurring. It was a one step, immediately it went down. So the piston was slowly going down. Okay. Remember this thing? Remember one thing. If in your question, anytime it is mentioned that it is a multi-step process or etc etc, multi-step process means only you have to understand that there will be an integration. Okay, there will be an integration. Now let's start with this sum. What is the general formula for work done? Minus P external delta V. Okay. Now, I told you that the piston was slowly going down. Okay. So obviously the gas inside, the gas below the piston was also exerting some kind of force on the piston. So here P external, that is the pressure which is given by the piston, is equivalent to P internal almost. It is the pressure which is exerted by the gas. And in the what I will say, in the irreversible process, this was not happening. Okay, so irreversible process, you put a brake and immediately the piston goes down. So the gas did not get enough time to push it back. But here slowly it is going down. So P external is almost equivalent to P internal. So I can, and I told you that it is occurring in multiple steps, right? So you have to consider those multiple steps, work done by multiple steps to calculate the actual work done. Okay, so we will be writing it like this: minus of integration P internal dV. This and this is same. In Greek, this is the capital letter, this is the small letter. Okay, both are same thing basically. And the integration will be initial volume to final volume. Now, we can write it as, again, this is a ideal gas. PV is equals to nRT. So what is P? nRT by V, right or wrong? So I can substitute it like this. P internal is nRT by V into dV. This is a constant part. This is the constant. Okay. So in your integration, your someone who teaches you maths will tell you that during your integration, you take this constant part out like this. V1, V2, dV by V. Okay, this has a formula. What is the formula? It is ln V. With the limits. I am writing it here. nRT what is ln?
Log.
Not log, it is ln. ln V2 minus ln V1. So minus nRT. We can write it like this. ln V2 by ln V1. So if you want to consider ln to log, minus 2.303 nRT log of V2 by V1. Okay, so work done is minus 2.303 nRT log of V2 by V1. Okay, this is one of your formulas. Now, for your isothermal process, this is an isothermal process though. For isothermal process, P1 V1 is equal to P2 V2. Okay, so P1 by P2 is equal to V2 by V1 for isothermal process. So this same formula can be written as minus 2.303 nRT log of P1 by P2. Okay, you have to remember what? If in your question you see reversible isothermal process, work done will be either this or this. Okay, for reversible isothermal process, this is the formula and this is the whole derivation. Is this part clear? Yes or
ma'am.
no?
Yes, ma'am.
Everyone clear? Now, so
Yes,
we
ma'am.
have completed for the isothermal process. Now we will be learning for isochoric process. What is the formula for work done? For isochoric process, what happens? It's just simple. Isochoric process, I told you, there are no such conditions. So you have to, for isochoric process, you have to use this formula only. Minus P external delta V. That is minus P external V2 minus of V1. Okay. This is for the isochoric process. Sorry. This is for isobaric. This is for isobaric process. Okay, next comes our isochoric. What is isochoric process? Isochoric process means delta V is equal to 0. What is our general formula? W is equals to minus P external delta V. So, minus P external into 0 is equal to 0. Remember, for isochoric process, the work done will always be 0. For isobaric process, use the general formula like this. These are the formulas you have to remember. For isochoric process, this work done will be 0 ultimately. And this is the derivation. Derivation, I don't think anyone will ask you ever in your life. Cyclic process. Cyclic process again a good thing. Cyclic process. What is the cyclic process? Someone has asked question. Okay, no. Remember, in thermodynamics, we always consider PV work, whether it is physics, chemistry, whatever. Basic concept remains same. But I guess in physics, their sign is just the reverse. Yesterday, I told you what is a cyclic process, right? Okay, so for the cyclic process, work done is equal to plus minus area enclosed by graph. So this looks like a square, but suppose this is a rectangle. This is A, this is B. This is A, this is B. What is the area of this? What is the area of this portion? Come on, what is the area of a rectangle? AB? AB to?
Yes, L into B, ma'am.
Yeah. So area is AB. For this also, this area, this part. Area is AB. Right. Now, work done for this process. If this is a cyclic process, if the arrows are in cyclic direction, see like this. If the arrows are in cyclic direction, you will put a negative sign. But if the arrows are in anti-cyclic direction, okay, like this. Cyclic is this, anti-cyclic is this. Anti-clockwise. If it is clockwise like this, you will put a negative sign. If it is anti-clockwise, you will put a positive sign for the work done. Okay, so did you understand how to put positive sign or negative sign? First find the area enclosed, then see whether it is cyclic or non-cyclic and accordingly solve. Is this part clear? Everyone respond. Is this part clear?
Yes, ma'am.
So,
Yes, ma'am.
yeah, this is clockwise, right? Clockwise means negative. Anti-clockwise means positive. Now, another system is present which rarely comes. It is open container. What is an open container? Open container means, suppose you are a scientist, okay, future scientist. Here, there is a chemical reaction. Here you are boiling some acid and something like that you see in your movies. Okay, here something is boiling and, okay, gases are being produced here. Okay, gases are being produced here. So this gas is doing some work with the atmosphere. Yes or no? We can't see, but the gas is doing some work with the atmosphere though. Whatever the gas is being produced from this chemical reaction, here chemical reaction is occurring. Right? Here the gas is reacting with the atmosphere. Okay. So what is the work done by that gas? So what to use? Work done is minus P external delta V. This is our general. Now, what is the P external here? Atmospheric pressure. Here, P external is atmospheric pressure. Okay, so minus P external, and what is the atmospheric pressure? 1 atm. So minus of 1 atm delta of V, right? We frequently write like this. So minus of delta V. Now, this is again an ideal gas. So for ideal gas, PV is equals to nRT. Our pressure is 1. Volume is V, nRT. Okay. But you can write here delta V. Okay. Instead of V, you can write here delta V. Instead of N, we write it as NG-RT. Okay. So what is minus of NG-RT? N remains moles only. Okay. But for like this, for this case, we write it as NG. So delta NG-RT. Okay. Delta N. So tomorrow tomorrow we will be doing the sums and accordingly we will solve. So work done is minus of delta NG-RT. Is this part clear? So for an open container, what is the formula for work done? For an open container, this is our work done. Is this part clear?
Yes, ma'am.
Tomorrow, just revise whatever we have learned. I have told you about today's class. What we have learned? We have learned about the basic definition. Okay, let's just recap. Today's class, everyone understood everything. See this. We started with deriving the basic formula for work done, which is W is equals to P del V. Okay. Now we have learned some exception. What are the sign conventions? Which are the IUPAC sign conventions? I told you if you are doing the compression work, you will get the answer in positive. If you are doing an expansion work, you will get the answer in negative. Tomorrow's class, we will see this also. Then we have done with the units. We know to convert what to what, we use what. Now, we have solved one numerical, rest of the numericals we will be solving tomorrow. Then, we have made conclusions about first law of the thermodynamics for each process, isothermal, isobaric, isochoric, and so on. We have made conclusions for each of them. Then all functions, we have got the conclusions, and then we have done the work calculations, like how this formula changes for each of the following. For irreversible isothermal process, reversible isothermal process, and so on. And we also know now what units to use. Okay. Is this part clear up to this? So we have learned for irreversible isothermal process, what is the formula and its derivation. We have learned about for the reversible isothermal process, what is the formula and what is the derivation. Okay. So for isobaric, what is the formula? For isochoric, what is the formula? For cyclic, how to use the sign convention, and open container, what is the formula. Okay, so this whole part is clear to you. Tomorrow we will be solving each and every questions, and after tomorrow's class, if you listen carefully, if you have revised, and if you understand tomorrow's class clearly, I'm 100% sure that you will be able to solve all the questions from this part of the thermodynamics up to first law. Okay. Everything is clear from today's class. So from tomorrow, we will be doing only the numericals. And then we will be moving to other parts. Is this part clear?
Yes,
Yes,
ma'am.
ma'am.
Good. Okay then. Ma'am, this was from my end.
Okay, ma'am, thank you. Students, you can join the next session. Join the next session.